In the STL, iterators are a generalization of pointers that allow access to STL containers with a consistent interface. Here I have a working copy of iterator.cpp from chapter 10 of the exercise files. There are 5 types of iterators. Some classes don't support all of the different types. This demonstration uses a vector type which supports all 5 types of iterators for demonstration purposes. So I'm going to just build and run here, and I'm going to scroll this output up to the top, and we'll go through this code and look at the different types of iterators. So here I have a vector. It's a vector of ints, and it's called vi1, and I've declared a variable of type iterator from this vector. And we're going to start with the input iterator. The input iterator allows reading from the iterator object without multipass guarantee. That is, rereading an object is not guaranteed to produce the same result. But in essence, what the input iterator does is it allows you to read from the object. So here I have a simple for loop, and I'm initializing my iterator variable from vi1.begin, which is always the beginning of a container. And I'm checking to see that it's less than vi1.end, which always points past the end of the container. And I increment my iterator variable for each pass through the loop. And then I read from the object. Notice the syntax. It's just as if I was reading from a pointer. So the asterisk and my iterator variable will return the object at that point in the container, at the point that the iterator is pointing to. And you notice my output, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is exactly what we would expect if this were a fundamental container like an array. So the whole idea of the iterator is that it allows you to access all of these different container types as if they were native fundamental type in C++. So now I'm going to save the start and end points. And so I have a couple more iterator variables, start and end, and I'm initializing them from vi1.begin and vi1.end. And this is something that you can do if you're not inserting and deleting objects from a container. Once you start inserting and deleting objects from a container, your saved iterators are no longer going to be valid. So you need to be aware of that. We're not doing that here, so this just makes the rest of this easy. We've seen how we access the iterator from .begin and .end, and we don't need to keep demonstrating that over and over throughout this code. So now we're going to look at the output iterator. An output iterator allows writing to the iterator object. In other words, it allows writing to the container that the iterator object is pointing to. It may iterate forward without multipass guarantee. So it's just like the input iterator, only it allows writing instead of reading. And so in this case, we're doing exactly the same type of loop. And I'm demonstrating writing to the object by incrementing what is pointed at by our iterator. And so this requires the parentheses around the asterisk it in order to have the pre-increment and the pre-decrement. So for each pass through the loop, I increment it and print it out, and then I decrement it so that it's reset to the way that it was before. And so you see the output iterator output here, instead of 1, 2, 3 through 10, it's 2, 3, 4 through 11. So I actually changed the values that were pointed at by the iterator. The forward iterator allows reading from and writing to the iterator object with multipass guarantee. That means that rereading an object is guaranteed to produce exactly the same result. And so I'm demonstrating it by reading the object twice with exactly the same result. And you can see here 1 through 10 followed by 1 through 10. And a bidirectional iterator allows reading from the iterator object both forward and backwards with multipass guarantee. And you want to notice here that the end iterator points past the last object of the container. So at the beginning of my for loop, I have to start at end -1 and go through greater than or equal to start. And you notice my bidirectional iterator here, I'm reading backwards 10 through 1. And finally, the random access iterator allows reading from the iterator object randomly with multipass guarantee. And it also overloads the array subscript operator. And so we're able to access with an iterator plus or minus a given offset, or using the subscript operator like that. And so there's our random access iterator output. STL iterators allow you to iterate through a number of different types of containers with a common interface. Not all containers support all types of iterators. In fact, not all containers even support iterators at all. The documentation for each container type will tell you which types of iterators it supports.